This video is going to be an extension on RP3, where we already had that Mr. Duke drove 120 miles in 3 hours. At the same rate of speed, how far can he go in 5 hours? We already worked that out, but now what I want to show you is how to put that in a double number line. So with our double number line, it looks very similar to where we had the scaling part yesterday where we went from the 3 hours to the 1 hour to the 5 hours. Same kind of concept here, except it's a double number line. Obviously, because we have one number line here that's representing miles on top and one number line on bottom that's representing hours. So on this, what we could say is if we know that we have 3 hours is 120 miles, now we can go back and say divide by 3 and get 1. So we're going to divide the 120 by 3 and get 40, which is exactly what we talked about yesterday, being the 120 miles equals 3 hours is the same thing as the 40 miles in 1 hour. So then in the problem it said 5 hours. So now that we have our unit rate, which is 1 hour is 40 miles, we can go over and say 1 times 5 is 5, and then 40 times 5 is 200 miles. So that still gives us the same thing. Now, what's great about this double number line is you can go anywhere you want to. Once you get that unit rate of 1, you can say 1 times 4 to find 4 hours, 1 times 6 hours. However you want to do that is completely fine. Also, you can do 1 to 2, and then from 2 you can go 4, 6, 10, 24, however many hours you're looking at that's a double. You could also go to 3 and then go to 3 to 6 to 9. That's also okay. Next one we're going to look at is we have 6 pounds of apples that cost $12. How much will it cost for 8 pounds? So we're going to put an X on top for our dollars because we do not know. Then we're going to crisscross multiply and get 6 times X, which is 6X. Then we're going to multiply 8 times 12, which is going to give us 96. Now, if you remember, 6X is the same thing as 6 times X. So we're trying to inverse operations here to isolate that variable. So we're going to divide by 6 on both sides. And so X is going to equal 16 here. So we can plug that in. So same idea, different type of situation, or same situation, different type of way to do this. We can go back and we can automatically put in our $16 here because we already know that. We just solved that by doing crisscross multiplication. Now we can go back and we can say, well, if we know that 6 pounds is $12, 1 pound is going to be divided by 6 because 6 divided by 6 is 1. Then you're going to say 12 divided by 6 is 2. So for every 1 pound, it is $2. This is the exact same concept that we're doing in a double number line. So if you have a 2 here, you could go 1 pound is $2, 2 pounds is $4. You could also draw you another line in between 0 and 2 and put a 1. If we know that we have 6 pounds is $12, we could go and say, well, 6 divided by 6 is 1, 12 divided by 6 is 2. So then you could go that way. It doesn't matter. Once you get to that unit rate, you can go anywhere. If you get to this 2, you could then go 2 times 2 is 4. 4 times 2 is 8. That would work. You could throw in a 5 right here if you needed to find 5 and say 1 times 5 is 5. 2 times 5 is 10. Double number lines are the exact same kind of idea we have with the scaling information. And you can also find all of these answers by crisscross multiplying.